Welcome to another video from explainingcomputers.com. A few weeks ago on this channel I looked at the RockPi4B. This is a very interesting single board computer. It's based on an RK3399 system on a chip. It's got a Raspberry Pi form factor. You can purchase it with up to 4 GB of RAM. It's got 2 USB 3 ports, and perhaps most significantly, it's got an M.2 slot which will take an NVMe SSD. And so in this video I'm going to return to the RockPi4B, and in particular I'm going to be testing out NVMe SSD performance and also looking at temperatures and cooling. So here's my RockPi4B just as we saw it at the end of my first RockPi4B video. And it's still fitted with a very large heatsink on the base. We'll be looking at heat sinks and cooling and temperatures a bit later in the video. And on the top it's got the M.2 Extender Board. And this, if you remember, takes basically a ribbon cable from the M.2 slot on the board itself round to the top so we can mount to here this WD black NVMe SSD. And some of you have asked, can you boot from an NVMe drive? And the answer is right now there aren't any operating system images that will do that. You have to boot from microSD card or an eMMC flash module, but there is a hope that in time you'll be able to boot from an NVMe drive. It's also worth pointing out this is the first generation M.2 Extender Board. There is a altered version coming out now, which apparently is a little bit shorter than this one, so it isn't longer than the board itself, and it gives access to the GPIO pins. And that new M.2 Extender Board, there is one racing towards me somewhere in the carriage somewhere. If I get it in time to put it in this video, I'll show it you a bit later in the video. Anyway, for now let's get this thing all connected up and we'll test out NVMe drive performance. So here we are running Debian on the RockPi4B, and as you can see I've installed HTOP. I know some of you like to see HTOP running to see everything going on in the background of one of these systems. It looks very nice, doesn't it? And I've also installed various other software to test things out since I last was showing you this board. For example, I've installed LibreOffice, and if we run up, say, LibreOffice Writer, you'll see it comes up nice and quickly. It's a nice responsive single board computer, the RockPi4B. Anyway, we're here to test out the speed of the NVMe drive and interface. So I'm going to launch a LX terminal, and I'm just going to rescale it a little bit for reasons that make life a bit easier in a second. Well, not quite like that though. Dearie me, you'd think I could do that better, wouldn't you? And yes, the screen redraw here is not absolutely perfect, isn't it? But anyway, let's put that there like that. I'm going to list the block devices. I'll do ls blk command like that. And that'll show us all the drives on this system. You'll see at the top there we've got both a microSD card plugged in and also an eMMC flash module. This system is currently booted from microSD card, but the eMMC flash module is still plugged in, which has got Android on it still for this machine. But down here you can see we've also got our NVMe drive, NVMe0N1. And to test out the speed of that, I'm going to use a very simple Linux utility called HD Parameters, HDPARM, which basically is a utility for looking at the parameters of a hard drive, or here an SSD, and including looking at its read speed. And I've already installed this on the system using this command here, sudo apt-get installed HDPARM, and that means I can now type in this command to do a read test. I can do a sudo HDPARM like that, and a -t, and direct, and then a dev, and then a NVMe, and it's a 0N1, isn't it? And this will basically run a read test on the drive, and it won't involve any buffering. This will be a direct read test to give us, I think, the most accurate indication of the speed of that NVMe interface. So let's press enter on that, see what happens. Very exciting, shouldn't take it very long. There we are, direct disk read going on. And what have we got? 495 megabytes a second. And let's just do a couple more iterations of that to make sure we get a reasonably accurate result. Should be okay to use one, but we might as well be a bit more scientific. There we are. Oh, look, that's pretty similar, isn't it? So we'll do a final one there, and oh, suspense. Is it going to be 276? No, it's going to be 496. So as we can see, we've got just under 500 megabytes a second read speed here over across that interface. Now, how you interpret that depends really on the context and what your parameters are, because as you may remember, I have tested out NVMe SSDs like the WD Black we're using here in previous videos. For example, here I showed how the speed of the drive on an i7 PC, which was 3,447 megabytes a second, and also on a Latte Panda Alpha single board computer, which was about 1820 megabytes a second. But that's a $400 single board computer, a lot more expensive device than the RockPi 4B we're using here. And I point out that about 500 megabytes a second is the fastest drive speed I've ever seen on a RK3399 based single board computer, or indeed on any ARM based single board computer. And to give you some comparisons of that, a while back I looked at the RockPro64 with a SATA card connected, and I got these results here for connecting a drive either via a direct SATA interface or via a USB interface to a SATA adapter. And as you can see, we've got a speed of about 260 megabytes a second. So we're getting roughly double the speed here using the NVMe drive on the RockPi 4B. And I'm sure that's got you thinking, what if you plugged in a drive using a SATA to USB 3 adapter onto this board, a device like the one we've got here? So I'll take this drive and I'll plug it into our system. Let's put it in like this, and hopefully it will appear. Oh, look, there it is. Look, no, we don't want to open the file manager. But if I do the LSBLK again, we should find at the top of the list, there it is. Look, it's found the SSD there as SDA1. And so if we just again do a test, but this time we change that to SDA1, we can get the speed of a drive connected, a SATA drive connected via a USB 3 on this board. Again, the suspense is killing us. What's going to happen? 259 megabytes a second. Let's try it again. Oh, I've gone quiet for a second as we look at the result. And, oh, 264. And we'll try it again. This is a very, very similar result to what we got on the RockPro64, isn't it? So there we are. If you connect drives using a USB 3 port here, using a SATA to USB 3 adapter, you're going to get about 250, 260 megabytes a second. Whereas if you use the NVMe drive, you get about double that, about 500 megabytes a second. So, here I am back again, and we're going to set up some temperature tests. And the syntax to get a CPU temperature measurement on a RockPi 4 looks like that. I found that in a very helpful RockPi 4 forum. And if we run that, we get a number here at 48125, which means 48.125 degrees C. Or if we add a bit of formatting in using all of this, we end up with a number with the decimal in the right place, 48.125 degrees C. So what we want to do is to find a way of stressing out the RockPi to get its processors at full utilization for a period of time. And to do that, I'm using the utility sysbench, which you can install using this command, sudo apt-get install sysbench. And I've been doing some experiments, and I've discovered if I use the sysbench syntax like that, it'll basically do a CPU test factoring prime numbers up to 22750 using all the processor cores. If I just run that to show you exactly why I picked those numbers, let's just run it like that. And if I bring up HTOP, you'll see it is working because all the processor cores are now stressed out to their maximum. So let's just fast forward to the end of this test. And there we are, it's finished. The utilization has dropped down to idling levels. And as you can see, this test took about a minute to execute. That's why I've come to this number 22750 for factoring primes up to that value, because it gives us a test that stresses out the processor cores for about a minute. And indeed, if we run the command here to get a temperature, you'll see the temperature is now, 50.55. It was 48.125. You can see that running that increases the temperature of the RockPi 4B. So to run that repeatedly over time whilst taking temperature measurements, I've written a little bash script which looks like this, which basically tells us it's a bash script, clears the terminal to be nice and tidy, reports on the temperature before we started the test. It then has a little loop which will run 7 times for f in the range 1 to 7, and then inside a do here it'll run sysbench as we're doing previously, but with some extra syntax on the end here, which will suppress its output. So we won't see all the sysbench text on the screen, we'll just see our numbers from the temperature test, and indeed there is the actual temperature test, and finally things are done. So this will give us 8 temperature measurements with gaps of 1 minute in between when the processor cores are all stressed out. So we're going to run this, but I'm not going to run it straight away because clearly it wouldn't be fair to start it now when I've been showing you some tests and things have been running. So I'll let the RockPi 4B cool down and we'll run our first temperature test. Right, for our first test using the large heatsink, as you can see I've inverted things, so we've got the heatsink on the top. That seemed most sensible to make it work best, and I put the base of the case on the base which covers the SSD. So we put that there like that, and we'll boot it up and go back to the desktop, and here we are. And this machine has been running about 2 minutes, so you'll get a good idle temperature when we start things off. Now if I just run up LX terminal, if I change directory to scripts, which is where I've got the script, to show you there it is sitting there. And I'd point out I've made temp sh executable by running this command here, which means that all I've got to do now is to go like that and temp and sh, which should start it off. And there it does. And you can see our idle temperature is what, a 33.33 with the large heatsink. So let's now speed through the rest of the test. And there we are, our 7-minute stress test results for the large heatsink. Rather a strange temperature profile there, a strange temperature curve, but that's what you get running a live test. And so let's now move on to repeat this test using the small heatsink. And as you can see by the magic of filmmaking, the small heatsink is now fitted. Again, things have had time to cool down and then to idle for a couple of minutes, so we can now run the small heatsink temperature test. And straight away we can see that the idle temperature is 10 degrees higher than with the large heatsink. So let's now speed through the rest of this test. And we finish with quite a dramatic 90 degrees C, the warmest I've ever seen for a single board computer's CPU. I think we've proved here categorically why it's a very good idea to get the large heatsink for a RockPi 4B. These RK3399 based single board computers, they do run rather hot, they do need some cooling. But you might be thinking, what if we added a small fan on top of the small heatsink? So let's now try that. And here we are, we've now got a 30mm 5V fan temporarily mounted on top of a small heatsink. So if we go back to the desktop, again things have been allowed to cool down so we get a good idle temperature, and we'll run for a third time temp sh. Oh, look at that, our idle temperature is now back to where it was with the large heatsink, 10 degrees off with that small fan. So once again, let's run through this test. And a very interesting set of results. Once again, a slightly strange temperature curve. That might be due to the tolerances in the sensors. But if we bring in all three sets of results together, we can clearly see that the small heatsink plus fan is in many ways a better cooling solution than using the large heatsink. Although, of course, the large heatsink is neater and it's also silent. So there we are. There are some hopefully useful test results if you're interested in doing high performance tasks on a RockPi 4 single board computer. Now, as I'm in RockPi 4B testing mode, I thought I'd just show you Android, because in my last RockPi 4B video I struggled to get into the Google Play Store in Android, but this is a later version of Android released a few days after I've made my last video. You can see there's no recommendations on the screen because I've turned them off, but we can get into, say, the Google Play Store there, I think. And yes, we've got Google Play Store available, no problems at all on the RockPi 4B in Android. This is Android TV. And if I go into settings here, you will notice that I'm actually running here in 4K, which some of you asked me to do last time. Let's go into display and HDMI. And as you will see in resolution here, I'm running in 4K. I'm currently running in 25p 4K because that's what I'm recording in, but the board will clearly go higher than that if you need it to do so. So let's come out of this and we'll just go back to the desktop and go to the Rock Media Player. You can tell what I'm going to do, can't you? Yes, I'm going to play a 4K file, and if I go across to videos, I've got a drive plugged in files there with in there hopefully a 2160p file. There it is, and if I play that file, we're now going to be playing 4K video on the RockPi 4B. So I just thought I'd show you that 4K playback is absolutely fine on the RockPi 4B. Right, it's now time for a world exclusive because I've just received this shiny package via DHL from my friends at AllNet. This is the new modified M.2 Extender Board for the RockPi 4. So let's get inside. And whilst I get into the package, I should just note that this is one of the first production samples. So this even has got some hand soldering on apparently to get it to me in time for this video. So the final board won't be quite like this, they'll be a bit neater, but the basics of the actual design will be exactly the same, of course. And if we open it up, we've got all the basic mounting hardware as previously. And yes, you can see they've got some now gaps here to allow access for GPIO. And as I suspected, what they've had to do is to move the ribbon cable connector, because this is the M.2 connector, and I imagine it has to be under there, doesn't it? They couldn't get them both on top. Let's compare this to the previous board, which is here, the one we were using earlier, where this has got its ribbon cable coming out the end. This board is clearly longer, whereas this one is the same length as a Pi, and therefore they've had to move that bit underneath, and we've got the space for GPIO, as I've said. So let's go and fit this onto the RockPi 4B, and here we are. And I have to say, this is a great example of iterative design, which is just so much better than the previous board. It's nice having it the same length as the Pi. It's great to have that GPIO access. And I'd also note that the ribbon cable is just a little bit longer, which means if you want to get to things like the SD card in here, it's easier. And in fact, even having on the other side this cutout just means you can get to things like the connectors, particularly the camera and display connector in there, just better. So that is a nice thing to see. So many of you in the comments on the previous video looked at the previous board on top and said, oh, it's too long and we can't get to GPIO and that type of stuff. And your comments have been responded to with this new modified version of the M.2 Extender Board. So thanks greatly to AllNet for sending it on so I could include it in the video. And I think it's a very nice upgrade to the RockPi 4 range. I'm increasingly impressed with the hardware in the RockPi 4 range. And here I've been using a RockPi 4B 4GB, but one of the things that most impresses me about the range is that you can buy a RockPi 4A 1GB for about $40, which means you can buy a single board computer with an M.2 slot, which will take an NVMe SSD for about $40. That, I think, is a really interesting development. It opens up all kinds of possibilities. But now that's it for another video. If you enjoyed what you've seen here, please press that like button. If you haven't subscribed, please subscribe, and I hope to talk to you again very soon.